What's up, people? I'm back. Alright, so as we're getting ready to get into some more of this stuff about proportional relationships and all that good stuff, we're going to talk about dividing fractions and mixed numbers here a little bit, because it's probably been a few weeks since we've done this, so we're going to focus today on dividing fractions and mixed numbers. Alright, so I'll play a little more of this for you at the end. Alright, so let's get into dividing fractions first. Okay, so the first section, okay, section 1, we're just going to do some with fractions. Alright, so let us say, friends, that we have something like 5/8 divided by 3/10. 5/8 divided by 3/10. Okay, so we want to use the old keep change flip. We're going to turn this into a multiply problem. Okay, we're going to do a little keep change flip. And of course, if we keep it and then we change it to multiply and we flip that over, our problem would be 5/8. If we keep that, change that to multiply, use the reciprocal of that, which would be 10/3. Okay, so keep change flip. Correct terminology is multiply by the reciprocal. You're going to hear me use that word. Okay, I'm going to try to teach you the right mathematical vocabulary. So we are multiplying by the reciprocal here. All right. Then I'm going to look at that and say, well, can I cross reduce the 5 and the 3? No. Can I cross reduce the 8 and the 10? Many of you would say no. Okay, but it's actually a yes, because 2 is a factor that can go into the 8 and the 10. Okay, so 2 can go into 8 4 times, and 2 can go into 10 5 times. So you can cross reduce there if they have these common factor. So I'm going to cross reduce them jokers. Now it leaves me with 5 times 5 up here, which is 25, and 4 times 3 down the denominator, which would be 12. Alright, so now I've got my improper fraction, 25/12. How many times will 12 go into 25? 2 times 12 is 24, so that would be 2. And then I'd have 1 left over, so I would have the remainder up there, 2 and 1/12. If you changed it back to a mixed number, okay, 2 and 1/12. Alright, so what that really means is 2 3/10 will go into 5/8 plus a 12th more. Okay, so 2 3/10 plus a little bit more go into 5/8 twice. All right, let's try another one here. So that we'll number that one number 1. Let's come down here and try another one, just with fractions. All right, just with fractions. All right, let's say you've got. Well, let's do this one. That's good. 9/10 divided by 12, just the whole number. Alright, some people freak out over that. Ain't no need to freak out over that. Okay, so don't let that bother you. First of all, 12 is a whole number, so what do you put the whole number over? We always want to put the whole number over 1. Okay, so just take that whole number, put it over the denominator of 1. Alright, so whole numbers go over 1. Alright, so anytime you got a whole number, just like I have a denominator of 1. Alright, so now we're going to do our keep change flip to this little problem. Keep change flip. Alright, so I'm going to keep that. That would be 9/10 times 1/12. Now again, you could go ahead and multiply that out and then have to simplify it at the end. But let's go ahead and do our cross reducing here, just like we did in the first problem. Can I cross reduce the 1 and the 10? No. Can I cross reduce the 9 and the 12? Yes. What's the common factor that goes into 9 and 12? If you're saying 3, you're right. So 3 goes into 9 3 times, and 3 goes into 12 4 times. So I cross reduce there by 3, and now I multiply it out. So 3 times 1, of course, is 3, and 10 times 4 is 40, and that would be it, because I cannot simplify 3/40ths. Okay, 3/40ths is it. Good job. All right, so now I'm going to give you one to try here, and I'll be quiet for a second, and we'll see what you come up with. Let's say you've got 6 divided by 4/7. All right, 6 divided by 4/7. On your mark, get set, go. Okay. So I'll start out by saying again, 6 is a whole number, so I'm going to put it over 1. Alright, and if I do my keep, change, flip to that, that would be 6 over 1 times 7/4. Now, can I cross reduce the 1 and the 7? That's a big no, sir. Can I cross reduce the 6 and the 4? Do they have a common factor? Yes, sir. What is my common factor? 2, sir. So how many times will 2 go into 4? 2, sir. How many times will 2 go into 6? 3, sir. Alright, so now I'm going to multiply my numerators together. 3 times 7 is 21. 1 times 2 is 2. That, of course, is an improper fraction. How many times does 2 go into 21? 10 is my whole number. 10 times 2 is 20. That means I got a remainder of 1, so that would be 10 and 1/2. How can I write that as a decimal? All you smart people out there. What's the decimal for a half? 0.5. That's right, so it'd be 10 and 5 tenths. 10 and 5 tenths if you had to change it to a decimal. Okay, so that's doing them basically with just plain old fractions. Alright, let's turn it up a notch. What do you say? Let's do it with mixed numbers. Yes, sir. Alright, I'm going to slide my paper up. Ready? 1, 2, 3. Okay. Now, let's say we got some of these. Like, 3, let's make this number 4. 3 and 3/4 divided by 12.5. Okay. So when you have mixed numbers, what's the first thing you got to do? Got to change them to improper fractions. All right, change to improper fractions. All right, so 4 times 3 is 12, and 12 plus 3 is 15. So that would be 15/4. Over here, 2 times 12, 24 plus 1 is 25. 25 over 2. And at the moment, it's a division problem. Okay? 3 times 4 is 12. 12 plus 3 is 15. That's 15/4. 2 times 12 is 24. Plus 1 is 25. That's 25 over 2. Now, again, I'm going to take my divide problem, and I'm going to do keep, change, flip. So, keep, change, flip. Just going to come over here and rewrite it. That would be, keep that first one, 15/4 times. I'm going to flip or use the reciprocal of that, and the reciprocal of that is 2/25. And now I'm going to ask myself, can I cross reduce to make it easier? Can I? Yes. I can cross reduce the 2 into 4 for sure. 2 goes into 2 once. And 2 goes into 4 twice. Now, can I cross reduce to 15 and 25? Again, 15 does not go into 25, but they do have a common factor. What is the common factor between 15 and 25, you say? 5, I hope you say. 5 goes into 15 3 times, and 5 goes into 25 5 times. Okay? And now it's a much simpler problem. I can just multiply my numerator numbers together. That there would give me a 3, and 2 times 5, of course, is 10. And I can't do anything less, more to it than that, because it's already reduced to its simplest form. If you had to write it as a decimal, what decimal would you write as 3/10? That would be 0 and 3/10. That's easy, right? You just write it just like it is, because 3/10. 3/10 as a decimal. Okay, let's try one more of these that have mixed numbers in them. Here's your number 5, and then I'll really throw something at you on number 6. Okay, 3 and 1/3
divided by 2 2/5. 3 1/3 divided by 2 2/5. Change them into proper fractions. You ready? 3 times 3 is, plus 1 is 10/3. 5 times 2 is, plus 2 is 12/5. Keep, change, flip. All right. So that means that would be 10/3 times reciprocal of that would be 5/12. Can I cross reduce the 3 and the 5? No. Can I cross reduce the 10 and the 12? Yes. What's the common factor between them? 2. So 2 goes into 10 5 times. 2 goes into 12 6 times. Multiply my numerators together now. 5 times 5 is 25. Multiply my denominators together. 6 times 3 is 18. That's an improper fraction. How many times will 18 go into 25? I hear you say once, which is right. Now, how much am I going to have left over? 25 minus 18. 7. So put your remainder up there. So that would be 1 and 7/18. Okay, now I'm really going to mess with you. Last question. All right, in number 6, I'm going to put some negatives in here, okay? So I want you to continue to think about those rules. We're going to be using them from now on. So let's say we had negative 7 4/5 divided by 1 3/10. So I have a negative divided by a positive, okay? Negative divided by a positive. Now, just because we're not using whole numbers anymore, okay, the rules still say the same, okay? So, what is a negative divided by a positive? Going to give you, what kind of quotient is a negative divided by a positive? Well, if you don't remember, we're going to find out in just a second. So again, first thing I'm going to do is change this to an improper fraction. 5 times 7 is 35. 35 plus 4 is 39 over 5. And I'm just going to keep that negative sign with it, just going to bring that down. 5 times 7 is 35.
Dustin, can you come by the meeting?
35 plus 4 is 39. Alright, over here, 10 times 1 is 10, plus 3 is 13 over 10. Okay, now, still going to do keep, change, flip, okay? Still going to do that same thing. So it's going to be keep, change, flip. So keep that first one, negative 39/5. Change it to multiply, flip that over to 10/13. Alright, now can I cross reduce some of that stuff? Sure can. 5 goes into 5 once, 5 goes into 10 twice, 13 goes into 13 once, 13 goes into 39 3 times. So what's negative 3 times 2? Negative 3 times 2 is negative 6. 1 times 1 is 1. A negative divided by a positive is a what? A negative. So that would be a total quotient of negative 6. A negative divided by a positive is a negative. Okay? So we're going to be using some of those integer rules in our stuff with fractions. Okay? The integer rules for multiply and divide are the same whether it's a whole number or whether it's a fraction. Okay? Same either way. Alright. Now, I do have a riddle for you today. If you'd like to try the riddle, and you've made it all the way to the end of the video, here's your extra credit riddle for today. If I have it, I don't share it. If I share it, I don't have it. So email me what it is. If I have it, I don't. What is it?
Thank you guys. Hope everybody's staying healthy and hope everything's going okay. Remember, you can email me or call me in here if you need to call me. My number in here is 336-475-8845 extension 2443. If you need me, baby, that's 2443.
And hey, don't forget to change those things to improper fractions. Do a little keep change flip. Cross reduce them if you can. And I hope it all goes well for you. Hope to see you soon. Adios!